All right, welcome everybody. My name's Greg Camp, and welcome to the 66th Brick Forum virtual edition. Um, we have a theme that we want to try to follow with our virtual booth. It's going to be an educational theme. The first presentation I'm going to do is on vacuum and the importance of it. And people say, well, why are we talking about vacuum? Well, we're talking about vacuum because it's a common issue in the plant when we go into plants that factories still today tend to run with vacuum lower than what they can actually pull. So let's start this off. What is vacuum? Vacuum is a condition well below normal atmospheric pressure and is measured in different units. Could be PSI, bar, pascals, inches of mercury, and etc. How to measure it? First off, you can measure it with a gauge, pressure gauge. That if the gauge is exposed to atmospheric pressure, meaning you're not pulling vacuum, then that gauge should read 0 when you're not pulling vacuum. And then when you do pull vacuum, most of us would want to be pulling 28 inches of mercury when we're extruding, because it's possible to pull 28.9 inches of mercury at 791 feet in elevation, which is what we're currently at right now here in Ohio. But we don't really have anybody over 10,000 feet, which you'll see later on in the presentation. We don't have anybody over 10,000 feet, so we should all be able to pull 28 inches of vacuum. Here's your chart. As you can see, if you're 10,000 feet or less, then you should be able to pull 28.9 inches of vacuum. The next way to read it is with an absolute gauge. You can have a digital absolute gauge, or you can have the one with the mercury in it that's the little tube. The good thing about an absolute gauge is it requires no sea level, it requires no barometric pressure corrections, and it reads vacuum directly, requiring no initial calibration. And good vacuum on an absolute gauge would be somewhere in the neighborhood between 1.5 and 2.5. So basically that would be like pulling it on a pressure gauge. That would be like pulling a 28 inches of vacuum if you were pulling a 2. So absolute gauge are used a lot these days. I see them more and more instead of just having a pressure gauge. How to maintain good vacuum. We say, oh, we want good vacuum, but how do we maintain it? So to maintain a system with no leaks in the piping, the filter canisters, the dust boxes, the pug sealer, down the pug shaft, the vacuum chamber with the lids, inspection doors, and all the way up to the die. So the barrel, and yes, you can leak vacuum on the barrel of an extruder if you hadn't sealed everything up. Make sure inline filters are cleaned daily. Make sure the lower tank on the vacuum, if you have a typical vacuum system that's using some coolant that has an upper and a lower tank, make sure you empty the condensate water out of the tank daily. Install inline filters higher than the vacuum chamber. That'll help keep the solids falling out and not going to the filters. Consider using dust box between the vacuum chamber and the filters. That'll save your filters. You won't have to clean them as often. They'll be easier to clean. Make sure air cooler's installed where it can get good cool air. Be nice if it was on an outside wall. That's a clean air supply, and not dusty right next to a coatings mixing station or something like that. Also check your fluid filters that are attached to your recirc pump. These fluid filters typically have a bypass gauge on them, and if they're clogged, then they'll be reading in bypass. Also, a good practice is to date these filters so you know when they're last been changed, your fluid filters. You need to extrude with a full pug tub and a full extruder and have no leaks in the vacuum system. This is a typical arrangement for your double tank system. You see your fluid filters there above the recirc pump, and then you see your vacuum pump and your coolant, your cooling fan. One thing we'll see in this picture is maybe that cooling fan is not mounted in the best of places because it's right next to the pug sealer. It's very close to manufacturing, so if they could move that out on the outer wall into a cleaner environment, that would be good. Inline filters, you can see on this system that the inline filters have a dual filter system. The purpose for this dual filter system is so that you can clean one filter, you can close your ball valves and clean one filter while you're still running. So this doesn't create downtime to be able to clean filters. Also, they've added, if you look over there toward the vacuum chamber, they've added a pre-filter. And the reason they've done that, it's just one more step to try to protect the filters and not pull material back to them and make them easier to clean. Next thing, you can see this air cooler. It's up high. It's in a good clean air supply, and it's toward the outer wall. So this can get some good clean air. It's away from the extruder. Also, if you're going to run without leaks, you need a system to be able to find the leaks. This is a good system that's not very expensive. It's called a Traceline Marksman 2. It's an ultrasonic leak detection tool. We can supply this tool, or you can buy it from an auto parts store. They're sold in an auto parts store, but it's an inexpensive solution that anybody can use. And the directions are on a CD in the box, and it comes with its own carrying case. And it's basically, you put the batteries in, you put the headphones on, and turn it on, and you'll be able to find vacuum leaks and air leaks. Very simple to use and very inexpensive. Definition of pugging. Pugging is the process of working and tempering clay to make it plastic and uniform consistent. Effective pug sealing. To be able to do effective pug sealing, you got to have a full pug tub so that you maximize the residence time. Use the sealing section for pug sealing effectively. The reason I say effectively is if you have a worn out core, worn out shredders, worn out sealant augers, worn out liners, then you're not going to create any resistance or any holdback to effectively shear any material in the pug sealer. Just added here, it's good to have pressure control of your water system, high pressure atomization, spraying of water. This will all help you pull vacuum better because you'll be able to mix better, you'll be able to wet better. You should have consistent metering of your additives, all of them, whether they be dry or wet, and then consistent metering of your raw material feed, which will help you pull vacuum, because if you have consistent feed, then you're going to have a consistent tub level, which means you're going to be able to build a plug in the sealant auger section, and you're going to be able to pull vacuum without sucking back to the pug tub. And then it helps to have a good operator interface so the operator knows what's going on, and he can look at the the key numbers that he's watching to extrude, and to make sure he's got his additives, and to make sure he has proper vacuum and proper water addition. Here we got pug sealer level. One thing I like to do is I like to be able to show what's right and what would be wrong. And if you look in this picture here, this is too low. There's no way that you're going to effectively pull vacuum with running the pug sealer this low. You need the pug tub full so that you can fill the auger and create a plug in the sealing auger section, and then you won't be pulling vacuum back out of the tub. This is the correct way. This is how a correct level of tub should look. Then you get proper mixing, and you get proper seal in the sealing auger, which creates a plug and some hold back resistance so that you can pull vacuum and you won't be sucking back through the tub. Does anybody have any questions? If you have any questions, here's our contact information, and you can get in touch with us at any time. And I appreciate your time, and I look forward to spending more time with you during the forum. Thank you very much.